Hi everyone, again welcome to this lecture. This is again I want to remind you that the class that we are talking about is Linux programming and scripting. Today we are going to continue our lecture on Perl. We covered a lot of things about Perl so far. We started with just doing some really simple programming with Perl. Then we went into more kind of like we started learning about the data structure. We learned a couple of them. One is the main data structure that that is pretty much the workhorse of Perl is the scalars. We learned about scalars, and then we went into the arrays. Actually, in between we also learned about strings. We touched upon it. I think there is more to strings that we will be seeing in the future classes, in a couple of future classes. But now we are talking about arrays, and I want to continue our discussion on arrays. And today I will be finishing up with arrays so that you have a good understanding of how to represent arrays, how to use arrays in your programs, and how to manipulate various data using arrays. So all these things are the key things, key learning objectives from this session. So before I start with today's lecture, I want to give you a brief recap of what we learned in the last lecture. So let's begin with that discussion. So in the last lecture we first started talking about the range operator. I hope you remember the range operator, which is the two dots, which represents essentially a range of numbers, and it has two contexts that we talked about. One was this in array context, and the other one is the scalar context, and what is the difference between those two, that also we understood. Basically in the scalar context it also has the Boolean nature, so that it actually returns a true or false value. So that is one thing that we talked about. Then we went into arrays in more details. We understood how to specify an array and how the array literal works. Basically, what are the rules governing it in terms of putting a dollar in front, and then it needs to be in a square bracket that we need to specify. And then array itself, but the elements are specified in the regular brackets basically, and then we can specify each and every element inside that array, and then work on that. And then they are addressed using this the indices or index basically, which is specified in the square bracket. Then we also talked about slice. I just wanted to remind you about slice. Let's just quickly look into the slice operator. So the slice is essentially it's a shorthand representation of multiple elements of an array. So here this is something that we talked about. Basically the @ sign or the ampersand sign with the name, and then we can specify multiple elements as just with comma separated ones, and essentially that specifies which are the various elements of that array. And we also noticed some of the rules governing the slice. Basically, first of all, the indices need not be increasing, and the indices need not be different. Basically, the same indices also constitutes the slice. Then we looked at the stack essentially. Stack, as I mentioned, basically it's a set of memory basically which is stackable. You can say, like, meaning it has a property of last in first out. So that's what this LIFO means, basically last in first out, which means that essentially the elements that are added first comes out the last, and the last one that is added into the stack comes out the first. And the operation for putting an element in a stack and then removing the element in a stack, that's the two things. One is putting the element inside the stack is known as push operator, and then when you are removing the element from that stack, we use a pop operator to remove. And here you see one key difference between this and then regular arrays. You don't specify any kind of index, so you just say push at list, and then that is assigned to a new element, and then so basically it knows that whatever is last that you added, that element is actually, like, I mean, so the new element is added as the top of the array essentially, and it automatically increments the index, but the index is unknown to the user, so the user only sees the only one element of the stack. And then here is the pop usage of the pop one, basically where we are assigning the pop at list to this variable $top. And again, what this does is you don't need to worry about, okay, whether it is index 100, index 150, whatever it is, but the top of the element or the last added element is just popped, and then it's put inside this new variable $top. So this is something that we learned, and then we saw some examples of this, and more things basically that we saw. Then we looked at this shift and unshift. Again, these are some of the key elements essentially, which is kind of, this one is like opposite of push and pop. It's very similar, but it's kind of opposite in the sense that the shift is essentially like to the added, the element is added to the lower end of the array instead of the top of the array. So the last element is is incremented, last index is incremented, and then it's added to that. So here shift means basically like the last one that is got added, that gets popped out basically, and then it goes into the array, and then the array is kept as is essentially, like without that. And then unshift essentially, like, I mean, it puts back that at the top. So these are some of the useful commands essentially, like, I mean, so when we say like unshift 4, 5, actually, like, I mean, you can see that basically like the 99 is pushed, and then the 4 and 5 are added at the end. And then we also saw some examples of the shift command. Here is some more essentially. We are putting the thing inside that, and then we are also like shifting where the $x will get last as the value, and then essentially the remaining array will be intact. So that's the recap from the last lecture. Now we are going into the today's lecture. We will continue with the arrays. I want to introduce a couple of new things to you guys basically. So let's see. The first one is the reverse operator. Reverse is essentially used to reverse a complete an array with all the indexes or indices completely reversed. So so in this array, for example, so the $A is 0, 1, 2, 3. So this one you can say like it's the $A 0th element, this is $A 1 etc., and this one is like $A 3. So now we say the new array at B is reverse of at A. One thing you notice is essentially like when we declare a new array, we don't have to declare it upfront. We can directly make that assignment. In the modern Perl, actually we use my as a moniker for specifying a variable. It's a good practice to actually even if you are directly using it, to specify the array with the my in front. So this becomes like my, and then at B equal to. So this is a good practice. Whenever you're using the at B for the first time, use the my, then Perl knows that actually it needs to allocate the memory for this variable. So now let's look at this essentially. So when we say reverse, so we are assigning this as a reverse. So now for B0, that value is 3, and B1 is 2, and B3 is actually 0. All have a dollar in front. So in this example, we are printing the A corresponding A from 0 to 3. You can see that it's actually like 0 to 3, the values themselves. Whereas for B, the B0 corresponds to 3, and then B3 corresponds to 0. So we basically like the way to print out this is essentially like you can specify like I hope you remember all these things already. So when we escape this character, essentially we just print directly like at B, and then here this is literal because it's all inside the code. So it won't do this operation. It just prints out the same value. But when it sees this portion, it converts it into its array, and that is 0, 1, 2, 3. So basically like this is also like the way that you can write out this assignments. Okay, and then the other key function is the sort function. This is another one that you will be using more often in this in the real world. So here an array is given 7, 1, 9, 3, and then we say like okay, at B is sort at A. So now if we print out that B, it prints out 1, 3, 7, 9. So you can see that actually it's sorted the A in an ascending way. So this is an ascending sort. And then it prints out 1, 2, 3, 1, 3, 7, 9. And then the A is actually like you can see that actually it's kept the same thing basically. So the question for you is how do you do a descending order sort? Think about it. What can we do for a descending order sort? So one quick solution could be that we can just use this, first sort the A, and then basically like reverse it essentially, or you can say like at B equal to reverse sort at A. So this basically like you sort the array first and then put it into a reverse. What happens if you just do the reverse first and then sort? It will actually give you the same result, right? Because whatever you are reversing actually doesn't matter, and then basically like once you sort, you still get the same. So now what about this array essentially, and then what happens when you sort C? So Can you tell me like what happens again? This is, you should think about this as also like an ascending order sort, but now it's on the alphabets. So we know that actually like O comes before T, and then in this one also like TH comes before TW, and then finally this comes. So this is 1, this is 2, this is 3, this is 4, or in Perl notation this is 0, this is 1, this is 2, and this is 3. So let's see what happens. So here when we do the sort 1, see that this becomes like 0, 1, 2, and 3. So now we have another one which is like multiple numbers, all have different number of numbers essentially. This is just 7, this is 101, 29, 300, and if you do a sort, what happens essentially, like the sort does not go by the actual value of the number, but it's only a literal sort. So in this one, this is the first one, and this is the first number, this is the first number, and this is the first number. So it first sorts all the first numbers. So it comes up with 101, or essentially it's 1, 29, 1,000, and then 3,000, and then 7. So the final answer is actually, you can see that basically it only did the first number sort, the remaining ones it leaves open. So to achieve that, the real sort, what we need to do is we need to prepend with zeros, for example. So make everything like 4-digit number. So basically 0, 0, 0, 7, and then 0, 2, 9, 0. Actually, like we need to put one more, 0, 0, 2, 9, 0, 1, 0, 1, and then 3,000. If you do this number, then this order will be maintained, and then this is what we will get into as a result. Okay, so I think this is an interesting assignment, or an interesting example as to how to do the sorting. So now let's look at some more functions, essentially like chopping arrays. So we can apply many operators to an array. The operator is applied to all the elements of the array. So in this one, like so chopping is one of the operations that when we apply, this particular operator is applied to all the elements of the array. So the net result of this, like so if you do a chop on this particular array, can anyone tell me like what will be the result? So essentially like this element, this new line goes away. From this element again the new line goes away. What about this one? So let's see. So again remember, chop removes the last character. So from here this exclamation mark is removed, so we only get by. So if you do like a chop $stuff, this is what we'll get. We'll get the hello, we'll get the world, and then we'll get the by. You won't get the new lines from the first two, and then the exclamation character from the next one. So again, as I mentioned, like the earlier, the various operators have these various contexts, essentially the scalar and the array context. It takes both scalar as well as arrays as operands. It can return scalar and arrays as output. If we want an expression to be evaluated in a scalar context, we can force that by using a null string to it. So what do we mean by that? Let's look at some of these examples. So here is an array. Array is given as x, y, z, and then we print out these elements. Basically, it just prints out the same thing. Basically, x, y, and z. Now we say essentially like, okay, how many elements are there? So again this prints out when we include the comma operator. Basically, like it just concatenates everything and then prints out. Now there is the next one, which is we are concatenating comma to the array. Now what happens? So here essentially it only prints the number of elements, which is now it's no longer an array context. So this is all like array context. Now this in this example this has become a scalar context. So again we go back to the original rule. So in for the arrays essentially like again we can have the scalar context or the array context, and the operators essentially like so they can force we can make them evaluate as a whether a scalar context or an array context by just concatenating a null string to the array. So in this one we saw that actually once we give a null string basically in this case like a comma, which is now treated as an operator, and we are concatenating that to the this one to this array, and there now it is evaluated as a scalar and actually it gives the number of elements in the array as opposed to the literally printing all the elements. So here it printed out all the elements, whereas here it prints out just those the number of elements. We also saw like an operator to print out the number of elements in an array. I hope you remember that. I'm just going back to give you that information. This was covered in the last lecture when we talked about actually it's even before all these things. Yeah, right here. Length of an array. So this is another way to get the array length essentially, which is dollar hash array name basically. Or here we also mentioned that the dollar size is dollar array. So when we specify the dollar, actually like that changes this the context into a scalar context, and then basically like we get the length of the array. So I hope you remember that. So that's how we are printing that, and here we actually like printed out that with this is essentially like pretty much what we did at this point, which is we are concatenating with a null string. So here, and then that prints out the actual size. So think of this like we actually did this in the last class, and now essentially like we are just formalizing how we did it by describing this context essentially. So let's go back. So now let's look up at the some of the things that we have been learning earlier, which is stdin. As you know, like I mean, that is the input to the array from the terminal. So far, we have been learning that as a scalar context, where we actually used it to input one value at a time. Now let's see, like I mean, how we can use it to use it in a array context, and then see how can we use it in an array fashion. So in the scalar context, it returns the next line. This we saw actually when we studied about the scalars. Whereas in an array context, actually it returns the rest of the lines. So in an interactive mode, we need to use the control D, that is as the end of file character for Perl. So how do we use it is using these two notations. So if you do a $A equal to standard in, this is a scalar context. And if you use an ampersand A equal to standard in, this becomes an array context. So as you note, essentially, like I mean, it's basically like what you assign it to is how it determines whether it's a scalar context or is it a it's a array context. So now let's look at some examples also of how we can use it. And before that, let's look at what is the array variable interpolation essentially. So so first of all, in the print, we already saw that actually, like I mean, even within the double quotes, arrays can be interpolated and it can print out the values. So here, when we specify, like I mean, this is like you can see that actually it's not just a one either a numerical array or a alphabetical array. It's a combination of both, and it Perl actually cannot distinguish between those. I mean, it treats them as the same, so it's very versatile in that sense. So that's why, like I mean, print out A, B, C, and 1, 2, 3. When we use a slice, essentially, like I mean, so here it's 2, 3. So you know that this is index 0, 1, 2, 3, 4, 5. So now what it prints out is C and 1, which is the correct thing about index 2 and 3. So now when we do, this is much more trickier now. Like I mean, when we do the slice of at A, and then these 3, 4, 5. So now what should it print out? So 3, 4, 5, we know that it's actually like it's 1, 2, and 3. So when we do another add, basically, like I mean, that is it needs to print out this 1, 2, and 3, which is B, C, and 1. So let's see what it prints out. So that's it prints out BC1. So again, I want to reiterate this one. So 3, 4, 5. So first, it's basically like at A, the 3, 4, 5 evaluates to 1, 2, 3, and then it prints out what is 1, 2, and 3, which is BC1. So you can see that actually, like I mean, in this case, actually it is it's actually interpolating it twice basically. Like I mean, it's first interpolating first set of values and then it goes into the second set of values. And in this case, like I mean, if we make a mistake and say like 1, 2, 3 or something like that, in the first one, as we know, like I mean, then we just print out nothing because those A, B, C are not of real values, and as you know, like in slice function, we cannot have non-numeric values. So now let's see like how the array references are done in quotes. So in this case, like again within the quotes, this is actually interpolated. So A1 is, again I will mark these ones as 0, 1 and 2. So you can see that actually in this case it will print out the y because 1 corresponds to this one, so 1 corresponds to y. So the y will get printed out. Now let's see, like I mean, in another case, x is equal to $x, we are defining it as 3, and then $x minus 1. So what do you think this should print out? So in this case, again, this is first evaluated and then it goes and interpolates for the array value. So in this case, it should print out the z, which is what it does. Now when we do this one alone, what does it print? Any answer? It directly prints $3 minus 3 because see now it knows that actually it is a index context, but you know there is nothing there here, so it will print out directly this. So now we have a another question. If you want to print out this like say in kind of expression, what do we do? So one thing to note is essentially any this square brackets after a dollar variable is always considered as an array reference. So if we put like $A $x minus 3, it cannot understand that okay if you want to print out literally like I mean this way, you cannot print out because it doesn't know that okay this needs to be printed out this way. So in this case it returns just x, which is not what we want. We want to see like I mean $A $x or 3 minus 3, something like this. So to prevent that from printing just x and actually like stopping the interpolation of the array variable itself, we have to use either this or a concatenation or backslash. Like I mean all three are okay basically to do this one. So what do we mean essentially? Like I mean, so in this using the brackets essentially, so you can specify saying that dollar bracket A and then use the square brackets, and this is one way to actually avoid the confusion and print literal terms basically. So in this case, like we can do this way, and then this is evaluated as one, and then this is evaluated as a separate entity, and does not confuse with $A, this kind of an evaluation. So this is one way to do it. The other way to do it will be like $A and then you concatenate with it $x minus 3. So the concatenation operation again basically like avoids that confusion and make sure that um, we have the we will get the desired effect. And then third way is basically to use the backslash, which is like $a, and then back escape the square bracket $x minus 3, and then also escape with another square bracket. So all three can be used. Otherwise, it is just treated as the variable with an index. So let's look at some examples. Here x is an array and y is $3. So if you do a $x and in square bracket $3, this is actually like wrong because it's the single element array. So again, you know that basically a string is an array of characters, but when you specify like this, it's a single element one. And also, like I mean, in this one, this variable is treated as a scalar variable, so there is no array context to it, so it becomes wrong. So to make sure that we can print this way, what we need to do is essentially like I mean we do this brackets, use the brackets. So in this case, it will print as array element 3. So again, it's printing as element 3, even though this may not exist. Other way to do it is literal x concatenated with the column index. So that's also prints out as the same array number 3. And then the third one that we saw was to escape the various characters. So we can use $x escape the square brackets and then $y minus 1, and then this one, this will print array 2 or array literally like $3 minus 1, because it only evaluates this, it won't evaluate this function because there is these square brackets are escaped. So it just puts this and these values. At the same time, if there was such an array of $x equals say 1, 2, and 3, say 4, whatever. So in this kind of case, basically, if you don't escape this, if you miss these ones, then it will just print out. It will first evaluate this 3 minus 1, which is 2. So this is 0, 0, 1, 2, and then so it goes and prints this value. So it just prints 3, and then it will exit. So keep in mind this one. This will help you with a lot of bugs, avoiding a lot of bugs essentially. So I think this is one of the key things that we will learn in this class. Also, like I mean, there are some some other types of arrays that we will be learning basically in due courses. So I'm not going to go into like a lot of details at this point. I think like I mean right now like we have a lot more knowledge than what we started with which we can actually like now really go into more challenging doing some challenging work. So here is one quick quiz for you. So at A is defined as a 4 elements array. What is $A? If you specify $A equal to at A, what does that mean? And if you specify in parentheses $A equals at A, what does that mean? So I'm sure that you may have guessed it right away that this is something that we covered in the last lecture. So at A denotes the number of elements, basically sorry, the $A equal to at A, this assignment, it assigns the number of elements to that this one. So or converting the array context into a scalar context. So the answer is $A is 4. But what about this the second one? Essentially here it's actually like now it combines that. So what does that mean basically? So when we specify this one, this actually means the first element of this this array is assigned to $A. So this is something that we use not a lot of times basically, like so it is this. So if you specify, like I mean you can say that this is at arrays 1, 2, 3, 4, and then basically the first element is captured in $A, and then the remaining is like rest, and then that's this 2, 3, 4, and we will see, like I mean what are the some of the so Perl actually like assigns these numbers, these variables automatically. So in the next lecture, or I mean in the future lectures, we will see, like I mean how do we get this remaining stuff, because this is something that is a very commonly used operation. Even like I mean we can say in an say we'll say basically, like I mean read any line and then we will split on something, and then we can say like okay assign it to A, B, C in this context basically $A, $B, $C. What this means is basically, like I mean the first element, the 0th element is assigned to A, and then the 1 is assigned to B, and then 2 is assigned to C. And in this case, like I mean if 2 is not there, and whatever is the rest is assigned to C. So this is a useful operation, so try to remember this. We will be also like learning more about this, and then so this is pretty much like end of a one-dimensional array lecture. So I hope, like I mean this is useful, and right now we talked about just single dimensional arrays. We will go into more complex data structures, which are the multi-dimensional arrays essentially. Multi-dimensional arrays also we can use lists and lists of lists to represent these multi-dimensional arrays. We will learn about that again. Static assignment will still get like a lot more memory intensive in nature, so we will typically avoid that. But essentially, like I mean we will see how lists are done in Perl in the next class. So I think that's pretty much done. So let me just do a recap of what we learned today. So again we started with some other new elements in the array. With this basically like reverse function. So reverse function is essentially, like I mean it's an operator on an array, and we get the value as essentially the indexes being reversed in a reverse order. So if you have a 10 element array, when we do a reverse operation, it still returns a 10 element array, but the indexes are exactly opposite. So the 0th element will become the 9th element, and then the first element will become the 8th element, and so all the way, and that's the reverse operator. Then we also looked at the sort. Essentially, like sort is an ascending order sort. and it does not it's not a numerical sort per se. It's really just an alphabetical sort, but we can use it as a numerical sort if we give it sufficient number of numbers or make all the numbers same length, then we can make it as a numerical sort. And we saw actually, like, I mean, if we do the 7193, then it returns the proper way. And then we also looked at how to do a descending order sort, which is like 9731, how to get those numbers. And for that we use both the functions reverse and the sort, and then it can be evaluated together, and we will get the required required effect. And then even any string arrays can be sorted, and since the sort function is based on the alphabet, the string arrays will also be sorted in the alphabetical order. As in this case, basically it will be 1, 3, 2, 0. That will be the final number. So when you sort like length with multiple length numbers, you have to make sure you have to take care, because it will still sort based on the first number, so that you won't get the desired effect. Then we looked at the chopping the array. Essentially, like chop is when you use chop as an operator, that operator is applied to all the elements of the array. So here when you do the chop of at stuff, every element is getting chopped with the last character. So for hello and world, it's just a new line; those gets thrown away, whereas in by the exclamation mark goes off. Then we formalize the concept of the scalar and the array context. The first one basically we saw as to how to represent the array itself in a scalar and an array context. So in an array context, essentially, like, I mean, we just let it be, and then we get the answer as just x, y, z if the array's elements are those elements. Whereas if we concatenate the array with a null character, then we will get the number of array, or the scalar context, which is the number of elements inside that array. And so we get, like, I mean, the actual number itself. Then we also looked at the stdin as an array, because again every variable will have this scalar context and the array context. So if you specify like $a equal to standard in, then that assumes that it's a scalar context and it returns the next line. Whereas if you do an @a equal to standard in, then it keeps getting line after line until we hit Control D. So that is in the array context. Then we looked at how arrays will be interpolated in various situations, mainly to print arrays in codes. Essentially, like, I mean, we need to specify the codes, and then when we specify the array inside the code, that array will be evaluated, and then that's what the result will be. And then for slices, the same thing. Basically, slices will be evaluated, they'll be interpolated within the codes, and then it prints out the answer appropriately. Slice also can have like multiple evaluations, essentially, like, I mean, so you can evaluate it once, and then further evaluations will yield similar kind of things, basically. So you can have so this is something, like, I mean, to keep in mind, because we will learn about these kind of things in the multidimensional context as well. So in this case, essentially, like at 3, 4, 5 as a slice results in the values 1, 2, and 3, which again is a slice, and then those values are returned, which is B, C, and 1. So that's another thing that we learned in the context related, or how to interpolate. And then now let's look at that the other interpolation, essentially. Like, this is another thing that we learned. So when we try to interpolate arrays inside of the quotes essentially, like so it is evaluated and then basically completely evaluated and then we get the result. So for example in this one we got y as the result, and in this one we got a z as the result. And then the other thing that we also noticed was when we do this kind of like just the square brackets without any array specification in front, it literally prints out everything. So it prints out the square brackets, it prints out $x, which is actually 3, and then it also prints out this and this minus sign, so 3 minus 3. So this entire thing is getting printed out. So that leads to an interesting conversation. Basically, once we have the array reference itself, then how do we use that, or how do we distinguish between an array reference and a non-array variable? So there are 3 ways to distinguish that is described here, 1, 2 and 3. The first one is to use this the brackets essentially. So that's what we mentioned basically, like if $A is a scalar variable, we use dollar in brackets A to distinguish it between a scalar variable and an array with an index, and then use like $x minus 3. And then the second method is using the concatenation. So we, instead of saying that $A and then like this, we use the concatenation with the next one. So here essentially, like so this is treated as one literal variable and this is another variable. So whatever this variable may be evaluated, this is just represented as is, which is like this one, and then $x evaluated, which is 3 minus 3. So it kept that way. And then finally using the backslash or an escape character. This is this one basically, like which is used to escape various control values essentially. For example, here square brackets can be used in other contexts essentially for the representing the array index, but once we escape it, then a literal value is used, which is just the square brackets. So using that, we can actually get around mistaking the dollar variable for an array context. So this is something that we also learned, and here there is an example that we talked about. One thing to note here is when we have the $x as a scalar context, which is from here, if you use it in array context, Perl does not like it and it will error out. So here it explains all the 3 methods that I talked about essentially, like as to how to print the arrays. And then finally, like we also saw like a small quiz to distinguish between a scalar context and an array context. For example, in this one, it's a scalar context. This is the example that we saw earlier. So this prints out the number of elements of this array, which is the same as 4. And then the other thing that is of relevance is this using the parentheses to actually get values from $A or at A, which is the array essentially. So from here, when we assign that to $A, what we get is essentially the first element from the at A, which is actually element 1. So for the first one, the answer is A equals 4, and for the second one, the answer is $A equals 1. So I think like that's pretty much it for today. Once again, thanks for listening and thanks for all the things. Okay, I'll see you next time. Thanks.